Hello everyone, welcome back to my channel. This is Tamil Shelvi, Assistant Professor in the Department of Computer Science and Design, working at SNS College of Engineering. In this video, we are going to see about the topic main memory from the subject Principles of Operating System. Let's start. Main memory. So main memory, also called as primary memory or RAM, is the memory where programs and data are stored while they are being executed. The operating system uses main memory to load processors and manage their execution efficiently. So main memory management plays a vital role in the efficiency of operating systems. So what is main memory? Memory management is needed to keep track of which memory is free and which is occupied, and used to allocate the memory to process and reallocate the memory when process finishes task. So what are the characteristics of memory? So fast access, and if you power off the system, data will last and you have limited size and it is costlier than second memory. So we have a hierarchy design that consists of register, caching memory, main memory and secondary memory. Main memory, commonly known as RAM, is a crucial component for system performance, allowing quick access to data and program in use. The operating system manages the main memory, optimizing the performance and resource allocation. We have two different types of memory, which include volatile and non-volatile. Volatile is nothing but the random access memory, and non-volatile memory is nothing but the read-only memory, each serving specific functions. Memory management techniques. We have three types of techniques in memory management, that is contiguous memory allocation, paging and segmentation. Let's see one by one technique with example. The first memory management technique is contiguous memory allocation. In contiguous allocation, each process is allotted one continuous block for memory. So consider this example. Here we have three file names, that is abc.txt, video.mpeg4 and jtp.documents. So first abc.txt that allot the three blocks of memory, that is 0, 1, 2 continuously. And for file name video.mpeg4, we allot the memory for blocks 4 and 5 continuously. So in simple, if we allot the for each process, if we allot the memory continuously, that comes under contiguous memory allocation. So while allocating the memory in contiguous, we have two types of partitioning, that is fixed partitioning and variable partitioning. If we allot the memory size fixed, then the type is called fixed partitioning. If the length is varied, then the type is called variable partitioning. While partitioning the memory, we can face two problems, that is internal fragmentation and external fragmentation. So let's see what is internal and external fragmentation. So fragmentation, in simple words, that divide the memory into smaller fragments that are stored in different parts of your storage medium, such as hard disk or RAM. So what is mean by internal fragmentation? So internal fragmentation happens when allotted memory is larger than the required memory, that leading to the wastage space which allotted regions. So for example, if your process needs 18 KB, then the system allots 20 KB, then 2 KB is wasted. So this we call it as internal fragmentation. The second type is external fragmentation. So external fragmentation occurs when free memory is available but scattered in small non-contiguous block. For example, we have free blocks of 5 KB, 10 KB and 15 KB scattered in our memory, but a process need 25 KB continuously. So allocation fails. So this concept is called external fragmentation. And the third category is compaction technique. So the OS can use the compaction technique to rearrange the memory content wherever the free space are available by reducing the fragmentation that improves the allocation efficiency. So for example, consider in our memory we have three block of memory blocks free, that is 5 KB, 10 KB and 15 KB in size. So the new process needs 25 KB. So continuous allocation fails. So after using the compaction technique by rearranging memory contents all together, we can allocate this 25 KB to the new process. So second memory management technique is paging. So paging divides the logical memory into the pages, physical memory into the frames. So each page is mapped to a frame using a page table. So the third technique is segmentation. Segmentation divides the memory based on the logical units like code, data, and stack. Each segment has segment number, base address, and limit. So each segment represents different portion of your program or process. Next one, memory management function. Basically, we have three types of function in memory management, that is allocation, deallocation, and swapping. The first one is allocation. Allocation means giving out a space. When you open a program, the system allocate a specific amount of memory for it to use. So it finds an empty spot in the RAM and hands the key to the program so that it stores its data. So that ensured each application has sufficient space to execute without interference from others. Second one, deallocation. Deallocation means taking the space back. When you close the program, the system deallocates the memory. That means it clears the data and marks that spot as empty again. If it doesn't happen correctly, the system runs out of the memory, that we call it as memory leak. The third function is swapping. When the RAM gets completely full, the system uses this method, swapping. It swap out the program you aren't currently using, and it swap in the program you just clicked on it. The OS may swap the process in and out of the main memory to optimize the resources used, that allowing more process to run concurrently than physical memory can hold. So virtual memory is a technique that extends a computer's physical RAM by using storage space on a hard drive or SSD. So virtual memory is essential for modern computing, managing the balance between limited fast RAM and slower, larger permanent storage. It enhances multitasking, improves system stability, and allows the programs to exit physical memory limits. In this virtual memory concept, we are using the algorithm like LRU, FIFO to optimize the performance by determining which memory pages to swap out. So virtual memory allows execution of your programs larger than physical memory, that use the concept of demand paging, page replacement algorithm. For example, FIFO, LRU, optimal. Virtual memory improves the system performance and multitasking capability. So conclusion, think of the main memory like classroom benches. Students like process occupy seats. Seats consider as the seats as memory. So if seats are managed properly, everyone sits comfortably. So if not, space is wasted or overcrowded. So this is the example for memory management. So in future, advances in hardware and software will continue to evolve memory management techniques. So the main key takeaway is understanding the main memory management is essential for every developers and users. So here I add mind mapping diagram for memory management. So just pause the video and go through the mind map diagram to understand the concepts in simple way. So thank you for watching this video till the end. See you in the next video.